morphogenetic protein, these BMPs. These are really proteins that we all have naturally in our body and that have the unique ability to signal the cells to create new bone. And surgeons have been using these proteins in spine fusion or maxillofacial surgeries. And they are helping enhance bone healing. It's already $1 billion market. But it comes with two major drawbacks that are linked to the way this BMP is delivered. One, it's very expensive. It's huge quantities of this BMP for it to be effective. And two, it is an uncontrolled delivery. Meaning instead of staying localized to the area of the fracture, the BMP can actually diffuse away from the site. And it can actually create new bone in muscle tissue around the bone. So we don't want that. So we developed a technology to resolve these two issues. Our technology is called Phabios. It is a thin film that can be easily deposited on any kind of material, any kind of chemistry, shape, or form. And this micrometer thick film made of natural biopolymers can absorb and maintain to the surface BMP in its active form. The result is that we can really transform materials that are already widely used by surgeons, but not promoting bone healing, into bioactive, bone-promoting materials. The result is also a cheaper treatment for BMP because we don't have to use as much of it, and it also a more controlled delivery and potentially a safer treatment because the BMP is maintained to the surface of the material. Now today we're looking for partners both in the manufacturing of the materials and of the BMPs to make our vision a reality. And what we want to do is really expand the use of these BMPs to new materials and new applications so that patients don't have to suffer as much and that cost for society for these difficult bone injuries is lowered. Thank you very much.
This is our innovative sensor. This can be used to perceive what's around you in 3D at a very low cost. And it's made of two cameras. You have the processing on board. It runs in real time and small. And well, you can even power that with a battery because it's a low power system. We put many of those sensors on our car, driverless car. And what you can see here in the video clip is our driverless car running safely and managing the traffic in downtown Parma. And you can see there's nobody behind the steering wheel, and there is actually an open traffic. And well, the technology that we used is this. So we have many of those sensors, small sensors, and the look of the car is more or less like a normal car. Thanks to these small devices, we put them all around the car. And well, this is a kind of new technology which could be a replacement of the current sensors that others are using for their driverless cars. So this sensor is able to detect anything which is into a given volume. The volume can be small, the volume can be large, it can be deep, or can be arbitrarily shaped. And this is a very nice feature because you can use this device for many other applications. I'm talking about the application in, for example, surveillance, robotics, safety, any application in which you need to perceive something which is inside a volume. And I'm talking about monitoring volumes in front of doors, elevators, robotics, operator safety, airport security. We've been through this number of applications, and we run some feasibility studies. They were all kind of positive. So we ran some patents. We already have some patents on this thing. What we are missing now is the safety certification. So if we can get to the safety certification, we can really use that for so many applications. I know it's hard because we've been through that. It's difficult. But today there is no vision system which is able to reach safety levels that we need in this case. So today what I'm looking for is people that would like to help us turn this working prototype into a very unique sensor for a huge mass market. Thank you.